Okay, today we're going to start solving systems by substitution. In previous videos we solved by graphing. Now we'll use substitution. So in this video we will solve by substitution, compare how it's similar and different from graphing, and I was going to discuss no solutions and infinite solutions, but I think we'll do that in our next video. So we'll wait one video for this. Remember that a system of equations is two or more related equations. Two equations that for some reason we compare to each other or analyze in tandem. So far we've solved them by graphing. So like this one here has a slope of 1 and a y-intercept of 3. So it would start at 3 and go up 1, right 1. This is the line y equals x plus 3. And then this one over here has a slope of negative 2 and a y-intercept of 6, so it'd start here and go down 2, right 1. And it's going to graph like this. And their point of intersection was right here at the point 1, 4. So 1, 4 was their point of intersection. That's a point that works in both equations. If I plug in a 1 for x, I get out a 4 for y. If I plug in a 1 for x, I get out a 4 for y. That's the solution. Well, graphing is an okay way to solve if you have equations that set up to graph really nicely. But there are plenty of times that doesn't happen. So another method that we use to solve with is called substitution. Now I'm going to take this same exact system of equations, but I'm going to solve it by substitution. Substitution relies heavily on the meaning of the equals sign. Remember how we talked in the beginning of this class, at the start of the year, the word equals really means is or same. So if you have the equation y equals x plus 3, you're really saying the y variable is whatever x plus 3 is. It's like if x is 1, then y is 4, and if x is 2, y is 5, but y is whatever x plus 3 is. Well, since I know that y is the same as x plus 3, I can take this x plus 3 and plug it into the other equation's y. So I can take the equation y equals negative 2x plus 6, but then recognize I know that y is really equal to, I'm going to draw a downwards equal sign here, y is really equal to x plus 3. So I can say x plus 3 equals negative 2x plus 6. I took this x plus 3 right here and plugged it into this y. Notice now this only has one variable. It doesn't have x and y. It now only has x twice. And we can solve one equation if it has one variable. I'm going to add 2x to both sides to get 3x plus 3 equals 6. Subtract a 3 from both sides to get 3x equals 3. And if 3x equals 3, I divide both sides by 3, and we get x equals 1. That was the same solution that we got when graphing, x equals 1. Now we've only solved half of the problem. We found what x is. We still have to find what y is. We have to find both x and y. But at this point, that's pretty simple. See, I know that x equals 1. If I take the fact that x equals 1 and plug it back into one of my equations, like I'll plug it into this one because it's going to be really simple. If I take x equals 1 and plug it into the equation y equals x plus 3, well, since x is 1, that becomes 1 plus 3. And we get that y equals 4. So x equals 1, y equals 4, and our solution is going to be the point 1, 4. We've solved the system. Okay, so when you solve by substitution, you get a variable by itself, and then plug what it's equal to into the other equation. So here's some examples. In this first problem, I have this variable y all by itself. I know that it's equal to 3x plus 5. So I'm going to take this 3x plus 5 and plug it into this y right here. So the first part of the equation doesn't change. It becomes 2x minus 4. But that y that I have now becomes 3x plus 5. And notice how I put it in parentheses, because that whole 3x minus 5, 3x plus 5, is going to replace that y. but just the y, not the negative 4. The negative 4 is still there. In fact, now the negative 4 has to distribute. So this becomes 2x minus 12x minus 20 equals negative 30. I distributed the negative 4. The whole entire negative 4 has to go to both of these. So I have 2x minus 12x minus 20 equals negative 30. Let's combine some like terms. These are like terms, so I can combine them. This becomes negative 10x minus 20 equals negative 30. I will now add 20 to both sides, giving me negative 10x equals negative 10. Divide both sides by negative 10 to get that x by itself. This right here is negative 10 times x, so to undo the multiplication, I divide. When I divide both sides, I get that x equals 1, just like last time. Okay, now I'm only halfway done. I found out what x is. Now I need to go back and find what y is. So I'm going to take this x equals 1 that I have and plug it in to my first boxed equation. And this is where I think that boxes are really, really handy. They kind of just let you see where you should be jumping to next. I'm going to plug it into this equation right here. So that's the equation y equals 3x plus 5. But I know that x is now 1, so x becomes a 1. So y equals 8. My solution is the point 8, 1. Or sorry, 1, 8. I'm going to check that really quick. When you check it, here's the key. You know how I just plugged x into this equation to find y? I plugged x into that equation. When I do my check, I really need to check it in the other equation. I'm going to check it in this equation here because that's the one that I didn't use to find y. So I'm going to take 2x minus 4y equals negative 30. This is me doing my check right now. I'm going to plug in 1 for x and 8 for y, and I get 2 minus 32 equals negative 30, which is true. Negative 30 does equal negative 30, so it checks. So when you check it, just check it in the other equation, the one that you didn't use to find your last variable. Okay, I'm going to erase this now and do the next one. I'm going to do this one a little bit faster. I have y equals and a y equals. I have two y equals equations. So I can just take one, I can just pick one and plug it into the other. So that becomes negative x minus 5 equals 2x plus 4. Now I've got variables on opposite sides, so when I get them on the same side. In general, the best plan when you're trying to solve with variables on opposite sides is to move whichever one is less. So I'm going to add x to both sides because negative 1, this is negative 1 right here, negative 1 is less than 2. That just guarantees I'll have a positive x instead of a negative x. That's all that does. Okay, next subtract the 4 from both sides. And we get negative 9 equals 3x. Divide both sides by 3. And we get that negative 3 equals x. Okay, I'm halfway done. I have found one of my solutions, or one of my variables. But now I can take this and plug it in to here to get my other one. And again, this is why I use boxes. If you would rather, you could plug it into here. And you might want to pick this one because it has no negatives, and that's really nice. Picking an equation that doesn't have negatives makes it a little bit less likely to make a mistake. I'm going to go into the top one just to show you how to deal with these negatives, because you have to understand this is a negative x. So it's the equation, I'll write down here, y equals negative x minus 5. And I'm going to plug in this negative 3 for x. So it becomes y equals negative parenthesis negative 3 minus 5. The negative here stays there, and then the negative 3 plugs in for this x, so it's negative 3 minus 5. Well, negative 3 is just 3, and 3 minus 5 is negative 2, so my y point is negative 2. That means my solution is the point negative 3, negative 2. and I'm going to check it. Since I used this equation here to find the variable y, I'm going to use this equation here to do my check. Use the other equation, the one that you didn't use to find the last variable. So I'm going to take -3 and plug it in for x. And I'm going to take -2 and plug it in for y. So y became -2, x became -3. I get -2 equals -6 plus 4. And -2 does equal -2, so that checks. So this is my solution. It's a good solution. The point -3, -2 works in both equations. Now I could have just graphed this, and I would have got the same thing. This is set up in slope-intercept form, so graphing it's pretty quick and pretty simple. But I think you're going to find after a while that substitution just takes less time than graphing. And if the solution isn't a nice, clean whole number point, nice lattice point like this, then graphing isn't that helpful. So substitution is usually going to be more efficient and more precise than graphing. Okay. Now, here, so far I've done 3 problems, and every time I've solved for y, but it doesn't have to be y. It can be anything. Here we have an x equals equation. So I'm going to take the fact that x equals 3y plus 5 and plug it in for x. So I'm going to have 5, and then in parentheses I have 3y plus 5 minus 2y equals 51. Notice how I'm really particular with my colors. I recommend you do the same. The thing I'm plugging in for x, I always put in parentheses. The whole 3y plus 5 is going in parentheses. But I also change colors with it, just to make it really clear to me what it is I'm doing right now. I can actually state these are equal to each other because because x is 3y plus 5. So now I have 15y plus 25. I'm distributing this 5 minus 2y equals 51. Combine some like terms. 15y and -2y becomes 13y. I'm going to subtract 25 from both sides, which gives me 13y equals 26. Divide both sides by 13, and we have y equals 2. Sweet. I have y equals 2. Plug it into my first boxed equation. So that becomes x equals 3y plus 5, but I know that the y is 2. So x equals 11. My solution is the point 11, comma 2. But I'll write that nice and pretty. There's my solution. I'll check it. I'm going to do this really quickly, just kind of in my head. I'm going to plug an 11 in for this x, and that becomes 55. I plug a 2 in for this y, and that becomes 4. And 55 minus 4 equals 51, so it checks. I'd like your checks to be nicer than that, like I've shown before, but I don't want to spend too much more time. I don't want this video to be too long. Last one. I'm going to look here and decide which variable is best to substitute. Since this b is already by itself, I'm going to take the fact that b equals 12 plus a and plug it into the other b. You're always plugging in for the same letter, letter for letter. B plugs into b, x for x, y for y, whatever it is. So this becomes, let's go with some yellow here, a plus 12 plus a equals 10. There's nothing to distribute. You can imagine like there's a 1 in front of this to distribute if you want, but this is really just going to be a plus 12 plus a equals 10. Combine some like terms, and 2a plus 12 equals 10. Subtract 12 from both sides, and 2a equals -2. Divide both sides by 2, and a equals -1. Since I know that a equals -1, plug it in up here. So b equals 12 plus -1, which means that b equals 11. And my solution is going to be the point -1, 11. When you're giving solutions, tend to give them in alphabetical order, please. A, B, X, Y, C, D, whatever it is, alphabetical order. Here's my solution. I'm going to check this in the other equation. -1 for A plus 11 for B does equal 10, so it checks. Systems can be solved by substitution as well as by graphing. If you have a variable that's isolated means it's already by itself. If you have a variable that's isolated, take what it's equal to and plug it into whatever your other equation is. Use parentheses to make sure you do your distribution correctly and to take care of negatives. Solve and check. You'll need to do substitution twice. Like first you find what A is, then you plug it in to find what B is. In our next video, we'll do substitution if a variable isn't by itself. So like here, we look at this, and we don't have x or y all by itself yet. So we have to identify which variable is best to solve for. That's in our next video, but I'll give you a hint. It's whichever one has a coefficient that divides everything cleanly. If I get this x by itself, I don't have any fractions, and I like that, because I subtract 2y from both sides. So anyways, that's our next video. See you then.